Determine the components of the force acting parallel and perpendicular to the axis of the pole. So if we have a force and we want to find the components, the equation from the book is AA equals magnitude A. Nope, I got that backwards. Magnitude A, the force A dot with UA. And the perpendicular, A perpendicular magnitude is equal to the square root of A squared minus AA squared. So writing this equation for our problem, we want the force OA magnitude is the force vector dotted with the unit vector in the direction OA. So the force vector, let's find that first. So we need to break this vector down into components. So it gives us two angles. The first one is 60. Now 60 degrees is between our first vector and this vector here, this component, which I call the fxy, because that is going to give the components of the magnitude of both the x and the y components here, whereas this is the z component. So fz is equal to 600 sine of 60, and fxy is 600 cosine of 60. So this is equal to 520, and this is equal to 300. So if we take that 300 and break it down further into x and y, fx then is 300 sine 30. And we can see x is here, so that's going to be in the negative x direction. So let's put a negative on there, and that's negative 150. Fy is going to be 300 cosine 30 for this one, which is in the positive y, and that's equal to 260. So now our force vector down here is negative 150 in the I plus 260 in the j plus 520 in the k. Now we got to find the unit vector. So we'll start out with the position vector. So the position OA from there to there is negative 4 in the I plus 4 in the j plus 2 in the k. So the magnitude of that is equal to 6. 16 plus 16 is 32, plus 6 is 36, square root of 36 is 6. And the unit vector then is equal to the position vector divided by the magnitude. So negative 4/6 in the I, so negative 2/3 in the I, plus 4/6 in the j, so 2/3 in the j, plus 2/6 or 1/3 in the k. So now we need to put those into here and dot them. So FOA is equal to this vector, negative 150 in the I, plus 260 in the j, plus 520 in the k, dotted with negative 2/3 in the I, plus 2/3 in the j, plus 1/3 in the k. So negative 150 times 2/3 is 100. 260 times 2/3 is 173. And 520 times 1/3 is also 173. And we sum that up, and FOA is equal to 446. And that is the force in the direction of OA. Now the perpendicular force, we'll use this equation. So we want the square root of the vector 600 squared minus the parallel component 446, and that comes out to 401, and that's in pounds.